Okay, question 19. Which one of the following is a sufficient condition, yeah, for the equation x cubed minus 3x squared plus a equals 0, where a is a constant, to have exactly one real root? Okay, so this is a cubic, right? And when we talk about roots, we always just draw the graph, right? So cubics have two shapes, right? It's either like this, yeah, with two lumps, or it's just, one go, right? What's the difference? I've said this like 10 times. The difference is that the left-hand side has two turning points, right? Okay, so we check if this cubic has two turning points or not. So to find turning points, we differentiate. So 3x squared minus 6x equals to 0. We check, right? So x equals 2 or 0, right? Okay, so that means that there are two turning points. And the two turning points are at 0, so this is 0 something, and 2 something, right? Okay, so how do I make sure, that the turning point down below, how do I make sure turning point down below, or what am I talking about? How do I make sure that the equation has exactly one real root? Well, there are two ways, right? You either make sure the turning point down below is above the x-axis, so it looks something like this, right? Or you make sure the maximum, the turning point above, is below the x-axis. So the x-axis would be flying up there, for example, here, right? Okay, so let's actually figure out what the question marks are first. So when x is 0, this is a, right? When x is 2, that's 2 cubed minus 12, right? And then plus a. So 8 minus 12 plus a, so that's a minus 4. Right. So we're going to make sure either a is less than 0, right? That makes sure that the maximum is below the x-axis, or the a minus 4 is greater than 0. Right? Okay, so either a less than 0 or a minus 4 is greater than 0. So I can take a number line, either a less than 0 or a greater than 4, like this. Right? Okay. And then you see, well, none of the options, are these pair of inequalities, right? But don't panic, because I want a sufficient condition. Yeah, I don't need the exact condition, right? I just need a sufficient condition. I don't need a necessary condition, right? Okay, so, all right. So if a is greater than 0, is that okay? Well, not quite, right? Because you have this section. This section is not allowed, right? Same thing. A less or equal to 0, is that okay? Well, not quite, right? Because I need a less than 0. I need strict. This is strict, yeah? That's why B is also wrong, right? Okay, how about C? Same logic. I need it to be strict, yeah? So C is also not okay. D, well, again, if you go D like this part is not taken care of, so D is not good. How about E? E is actually good, right? E, you have absolute values here, and you want to go left-hand side. That's all covered. So E is good, yeah? And you can check the rest. Why is F not good? Well, F is not good because, again, this section is not taken care of. G is not good because, it's, again, in that blank section, and the H also in that blank section, yeah? So that's why final answer is E.